Howdy! Welcome back to Multar Aviation. So in this Part 9 aviation weather video series, I'm going to be talking about air masses, fronts, the wave cyclone model, and dry lines. So please subscribe because this video series is going to be a long video series for this Part 9 video series. And I'm going to be going through each of the different types of fronts, how the wave cyclone model affects occluded fronts. I'm going to explain dry lines so you understand what that is, and you don't want to miss any of it. So if you subscribe, you get notified, and it helps the algorithm. So, all right. But anyways, I'm Dr. Andy Molter. I'm a flight instructor, CFI IMEI. I'm a former corporate pilot, and I'm a professor of aviation. And aviation weather is one of the classes I teach. So you're getting a free college education just here on YouTube. All right. So in this video, I'm going to be discussing air masses and their classifications, including their temperature properties and their moisture properties. And then in this video, I'll also talk about air mass modification. But in the next videos, I'll be talking about warm fronts, cold fronts, stationary fronts, and occluded fronts, and I'll also discuss the wave cyclone model. So an air mass is a large body of air with generally uniform temperature and humidity. And so, it's just a big body of air, and they do move, but the air mass source regions range from extensive snow-covered polar areas to deserts to tropical oceans. And the way that we classify air masses is is according to their temperature and moisture properties. So I'll come back to this air mass classification, but I just kind of wanted you to see, what we've got here. So here on top, we have the continental Arctic air mass. We have maritime polar air masses, continental, polar, and so on. And so for air mass classification, for temperature properties, we'll classify them as either Arctic, polar, or tropical. So an Arctic air mass is extremely deep, cold air mass which develops mostly in winter over Arctic surfaces of ice and snow. Whereas polar air masses, it's a relatively shallow, cool to cold air mass which develops over high latitudes. And then tropical air masses are warm to hot air masses which develop over low latitudes. So that last classification was based on temperature, and the other way that we classify air masses is through their moisture properties. And so we have continental and maritime. So continental is a dry air mass which develops over land, whereas maritime is a moist air mass which develops over water. And so when we combine the temperature and humidity, we then classify those air masses as either continental Arctic, which will be cold and dry, continental polar, which would also be cold and dry, continental tropical, which will be hot and dry, maritime polar, since maritime, the sea, so maritime polar will be cool but moist, and maritime tropical will be warm and moist. Now, it is possible to have maritime Arctic, but it's not listed in that 5 air masses that I gave you because it seldom, if ever, forms. And so here you can see how we have at the top here continental Arctic. So it's going to be cold and dry. And then below that, over like Canada here, we have like continental polar. So it's also going to be dry. And notice because both of these are over dry surfaces, and it's cold. But then when you have an air mass that starts over the sea, then they'll be moist, so maritime, and it just depends on the temperature, polar, because it's cold, or maritime tropical, because it's warm. And then as we'll see in the next slides here, as an air mass moves, then it moves over land, it could be continental tropical. So it would be hot and dry. So air mass modification. As the air masses move around the Earth, they can then begin to acquire different attributes. So example would be like an Arctic air mass that moves over the ocean that picks up some warmth and moisture, becoming a maritime polar air mass. So it was, extremely cold, but it was over the land that was dry. But as it moves over the ocean, then it picks up a lot of that moisture through like evaporation, and so then it becomes maritime polar. Another example would be like a warm, moist air mass that moves over a cold surface, which will then produce stable air associated with which will then create, you know, stable effects, which would be like stratiform clouds, fog, and drizzle. And so here's an example of that. Here on the left, we have a warm, moist air mass that moves over a cold surface. And then because it's stable air, you'll get stratiform clouds, fog, and drizzle. And lake effect, we'll see this. We talked about the lake effect in the last video. But you can see how the lake effect shows what happens to an air mass as it moves over different surfaces. So the lake effect is the effect of any lake in modifying the weather near its shore and for some distance downwind, which we call the leeward side of the wind. And so it's experienced around the Great Lakes and sometimes Great Salt Lake in Utah. And it can sometimes generate spectacular snowfall amounts on the leeward side of the Great Lakes, which we call lake effect snow. And so here on the left, we have cold, dry air over land that, the wind pushes it over the water. And it's possible that we get some steam fog, which we haven't talked about fog yet, but I will make a video specifically about the different types of fog. So make sure you subscribe. But as that wind keeps moving, it that it's picking up moisture, and that fog will lift to become a cloud, and then as it's moving, that cloud is growing, and then as it keeps growing, it just depends on the characteristics of the cloud, but if it's a stratus cloud, it needs it to be at least 4,000 feet thick for it to produce precipitation, which in this case is snow, and then it's continuing to pick up moisture from the lake through evaporation, and so then we get that precipitation where it moves over land and it gives precipitous amounts of snow. All right, that's it for this video. So in the next video, I'm going to be talking about fronts. So you definitely want to watch that. So please make sure to subscribe, and so that way you can get notified each time I come out with one of these videos. All right, well, thanks for watching. Let me know if you have any questions in the comment section. I'm happy to answer them. All right, you take care. Bye.